In this video, we are going to be talking about stacked data structures. So hey everyone, Mayank this side, and let's begin this session by first understanding the meaning of data structure. Back when the tigers used to smoke, I told you guys what is data structure. So let's have a recap of that. Data structure is a way of storing the data inside your computer so that you can use that data. And over here, the data represents that it is related data. So over here, in order to understand the data structure, let me just quickly create an example for you guys. And that example is of a school. So suppose you are a class teacher of a particular school, or I can say a particular class, and in that class you have one student and you have to store the data of that student. So in order to store the data of a student, you have the data like its ID, name, his address, and you have parents name and a lot of other things as well, but we are going to talk about these three things only in this session. So in order to store this data inside your computer, you have a lot of ways, and these ways are only known as data structure, how you are going to store the related data inside your computer. So let's have a look on stack data structure and try to understand what is this data structure. In order to understand the stack data structure, let me show you guys one example over here. As you guys can see on your screen right now, there is a pile of plates on the left and there is a pile of books on the right. So in order to access this books or this plates, I have to use certain operations. Or I can say I have to use certain rules. So let's first have a look on the plates and try to figure out what we can do out of this and how we are going to create stack with the help of these examples. So over here, you can see that we have a lot of plates on the top of each other. And if I want to access some plates, if I want to access a plate to eat something, I will be having only one choice, and that will be this plate. So I can access this plate only, or I can say this data only, which is at the top. Okay, so this is going to be my toppest position, and over here only I can access the data. And in order to access this data, I have to remove all these plates first. In the similar way, if I want to access this book over here, I have to remove all the books above this book. Okay, so that's what the stack is going to be. In stack, you have a lot of data on top of each other, and in order to access that data, you have to remove the above data first, or I can say you have to access the above data first. Okay, so this is the way you are going to work with the stack, and let me just show you guys a quick example over here to understand this thing in a more efficient way. So here, suppose you are going to a place where you have this type of plates and you are going to eat something. So you will take this plate from above and now you are done with the eating. But when you are done with the eating, you see that some people are coming and they are putting some more plates. So what will be the position they are going to put the plate? Will they put the plate over here or will they put the plates over here? No, they are going to put the plates above the existing plate only. And the reason behind is that if you put the plates in between, you are going to disturb this pile. And that's what we don't want. Okay, so suppose you want to add a new book to this pile. So what is going to be the best place? Above this all books only. So you can put the plates above this books only. You have no other choice. In the similar way, you can put the plate over here only. Okay, so let's assume this as a data. And now we have multiple data. So that's what a data structure is, storing of multiple data. So in order to access the last data, I have to first pop, or I can say I have to first delete this all data, or I have to access this all data in order to get this data. Okay, so let's have a look on the code part now, as we are going to do everything in coding only. So there is no meaning of talking about this images at some point. So let's have a look on how we are going to code this thing. So in order to understand the stack data structure, let me show you guys one more example. So here you can see we have an empty stack, or you can call this as an empty list. So now if I push an element, or I can say if I add an element, so adding is known as push in data structure. Okay, or I can say in stack data structure, when you add an element, you call as a push. Okay, so I'm pushing one inside this stack. Okay, and now I'm pushing two inside this stack, and now I'm pushing three inside this stack. So now when I do the pop operation, pop is going to be the deleting operation. When I do the pop operation, I first delete this element, and then only I'm going to delete this element, and then I will get access to delete this element. So everything will be in order. So if I want to delete one, then I have to delete 3 and 2 first. And if I want to delete 2, I have to delete 3 first. So that is the basics of LIFO principle. So LIFO is basically for last in first out, where you are going to remove the last element for the first. Okay, so this was the last element that was inserted inside this list, or you can say array if you are talking about C language, and you're going to remove this for the first. Okay, so last in, this was the last two in, will be the first two out. Okay, so that is the basic of stack data structure, and this is how the stack is actually working in reality. So now let's have a look on the operations that you can do in stack data structure. Basic operations of stack. Suppose you have created a stack. So now what to do? You can push an element, or I can say you can add an element. You can pop an element, or I can say you can remove an element. You can check whether a stack is empty, or you can check whether a stack is a full. And you can also check which is the toppest element in my stack. So you can just read these things out to understand what kind of operations you are going to deal with in stack data structure. So after getting set about what we need to do, now let's have a look on the algorithm of stack data structure. And guys, if you are good at coding, then this is going to be the end of the session for you guys, because I request you guys to please code this thing by yourself and then look at my code. Of course, this is going to affect the reach of this video, but still, please pause the video, get out of this video, and do this question by your own after getting about this algorithm, because I accept that you guys know the basics of programming. You guys have already studied about arrays or list. So after getting about these points, after getting about the algorithm, after getting about what you need to do, you can easily do that by your own. Still, if you need my code, you can watch. If you need the code in C or Java, then I will be providing the link in description where you can go and check out those videos, over where I have shown you guys the same code but in different language. Okay, so in this video we are going to talk about Python only. So let's have a look on the algorithm first, and then we'll try to code these things up. Okay, so the first line says that a pointer called top. So now don't worry about the pointer. This is not the pointer in the C. Yes, we have to talk about pointer at some point when we talk about the linked list, but for now you are free with that. And this pointer is basically a integer, a variable type of integer. Okay, and let's have a look on this. A pointer called as top is used to keep track of the top element in the stack. Okay, so I can understand what is going over here. It is saying that we have a pointer which is named as top, and this top is going to track the toppest element in my stack. So let me show you guys this thing over here. Suppose I have one inside my stack. Okay, so now I got one inside my stack. So now one is a part of this stack, and this is the only element inside my stack. So the top will point to this place. Okay, so the value of top is going to be 0. Why the 0? Because I have a list, and list or array doesn't matter. The index is going to be 0 for initial value. And as new elements are added, now I got 2. So top will now point to 2. So top will become 1. So now if I want to add another element, now top will become 3. Okay, so as soon as you add new elements, the value of top is going to be incremented, and it is going to point. That's why it is known as a pointer. It is going to be pointing towards the address of this element. Okay, so this is 3, which is at index value, I guess 2. Okay, so 0 1 2. So my top is going to be 2, because top is going to point the toppest element. Okay, so that's what the top is. Don't worry about the pointer that you have studied in C. It's not going to be that. Okay, so now let's have a look on the second line over here. When initializing the stack, we set its value to -1 so that we can check if the stack is empty by comparing top equal to -1. Okay, so I can understand this line over here. It says that we have to set the value of the initial value to -1, and the reason we have to initialize the stack, we have to set a value to -1, and we have to check if the stack is empty by comparing top equal to -1. Okay, so it is saying that we have to initialize the top with the value -1, and the reason behind this is very simple, because top is going to be -1. That means top is not going to point any value in the stack. Okay, or I can say in the array or a list in your case. Okay, so we have a stack. Now we are not going to call this as a list anymore, or a stack, or what do you call that, or array anymore. We are going to call this as a list. Oh, sorry for this. We are going to call this as a stack only. So this is my stack, and if I say -1, then -1 is not a value. I know you guys are thinking that -1 is going to be the last value, but please don't think about that. -1 is going to be the case where you have no value. Okay, so 0, we start from 0 1 2 and like this only. Don't think about that negative indexing. For now, let's have a look on this -1 as a no value case. Okay, that means our stack is empty. So we are going to initialize this thing with we are going to initialize our top with -1. That's going to going to give us the case where there is no value. Okay, so -1, when the value of top is going to be -1, it is going to suggest that your stack is empty. Okay, now let's have a look on the push operation. That is going to be the most important operation, because creating a stack is very easy. You have to just create a list. But now, how to push the elements? So in order to push the element, we have to increase the value of the top, and that is the most important part. Suppose my top value is initially 1. Okay, 2, let's say, 0, let's say. So I have my value as 0 over here because this is at the 0th place. In order to insert the new element, that is 2, I have to increment the value of top. Let's say top equal to 0. So now the new value of top is going to be 0 plus 1 equals to 1. So new element will be positioned at 1. So 2 is at 1. Okay. And if I want to access 3, then I have to just increment the value of top once again. If I want to push the value 3, then I have to do this again. So top is equals to 1, and I again want to add 1. So now the value of top is going to be equals to 2. So now 3 is going to be at the index value 2. Okay. And that's why we use top. We use top to add new elements inside the stack data structure, and we say that top is going to always point to the toppest elements inside the stack data structure. Okay, so over here, let's read the fourth point. That is going to be the pop operation. So in the push operation, you have to increment the value of top, and then you have to store the new element inside that value that is pointed by this top. So let me just show you guys a thing over here. Suppose you have a list like this, and in this list you have some values. Okay, so now if I say top equals to, let's say, -1. So now if you enter a new element, if you have a new element, add, let's say, 1. So when you add 1 over here, okay, this is not the case. Okay, so let me just take this. So if you have a list over here, okay, so I have to just reduce the size first. So okay, so if you have a list over here, and this list is basically set, we have some values like this. Okay, so now the value of top is going to be, you all guys know that it is going to be 1 because our last element is 5. Now in order to add a new element, let's say I want to add 7. So in order to add 7, I'm not writing a program, basically I'm writing a normal algorithm. In order to add 7, I have to first increment the value of top equal to top plus 1. So now the new value of top is going to be equals to 2. Okay, so now what I'm going to do is I'm going to say that list, and then I'm going to say that top, and value of top is going to be equals to 2 equals to 7. Okay, so now I have added 7 over here at the top of my stack. Okay, so this is what the use of top is going to be. And if you guys are not able to understand, then don't worry, I'm going to show you the code as well in this video only. Okay, so now let's have a look on the fourth line, that is the popping function. Okay, so pop an element. Pop is basically a deletion of an element. Okay, so you have to delete element, and the way you're going to do this is very simple. All you need to do is decrement the top. Okay, so you have to do top minus minus in C, and you have to do top equals to top -1 in Python. Okay, so this is the way you're, not this semicolon, so this is the way you're going to delete an element from your stack. So let me show you guys what happens when you decrement the value of a top. So when you decrement the value of a top, let's say your value of top is going to be equals to 2 over here, 1 over here, and 0 over here. So now you're removing this 3. So first what you will do, you will print that you're removing 3 by saying that print, and then let's say this is a empty stack. So let me just name this stack as a list. Okay, so what are you going to print? You're going to print list and then top. So this top is going to be equals to 2. So you will be printing 3. So you are basically printing that I'm removing 3 over here. Okay, so you are printing that 3. So you are printing that. Let me just write this thing over here. So you are just printing that list and you're passing top over here. Okay, so you are printing that you're removing 3. You can write the correct statements as per your wish. I'm just going to write that, yes, I'm removing the 3. And after doing this thing, what I'm going to do is I'm going to just say top minus minus, or I can say top equals to top -1. And by doing this, now the value of top is going to be equals to 1. Okay, so now the value of top will be 1. So the new toppest element is going to be equals to 2. So we are not basically deleting something. We are just changing the value of top in order to delete the toppest element. Okay, so this is the way you are going to delete something. Now we are not deleting it in reality, we are just changing the value of top. So nothing is deleted in real. Okay, so it is stored, it is still stored over here only, but now the value of top is 1. So we have no access to this 3. Okay, so we can't use that 3, and this is how it is deleted. Okay, so that's what the theory about deletion is going to be inside the stack. Okay, now let's have a look on the final statement, or I can say the semi-final statement. Before pushing, check if the stack is already full. Okay guys, if you want to push something, you have to first check whether the stack is already full or not, because of course I have some limits in data, in storing the data. So if my stack is of already, let's say, let me take an example here. If my stack can store only 5 values, so if my stack can store only 5 values, and I already got the 3. So I can only add 2 more values to this stack, and if I add any other value, then my stack will be full. Okay, so I can't add more than 5 values. Okay, so I can't add, can I say that I can't add more than when top is more than 5? So at this position, I will more than or equal to 5, because top is starting from 0, 1, 2, 3, 4. Okay, so I can't add anything greater than 4. Okay, so I can say that top should be never greater than equal to 4, greater than 4. Okay, it can be equal to 4, but not greater than 4, and that's what I want in order to solve the case where the stack is already full. Okay, so in the similar way, can I say that I cannot empty anything when my stack is already empty? Okay, so I cannot push anything when my stack is already empty. So how to check the empty case? I hope you guys know that. It is very simple. You have to check whether the top is equals to -1, and we guys know that we initialize the top as -1, which is the empty case. So if it is still empty, it is going to be equals to -1 only, and after every push operation, we are going to increment the value of top first, and then we are going to push the element at that particular location pointed by the top. Okay, and when we when we pop something, we first print the thing that this was the element you want to delete, and this is the element you deleted, and then we will say that top minus minus, and that's the way you are going to just delete, or I can say pop a element from the stack. Okay, and the way you are going to check for the empty case is very simple. You have to check whether the top is equals to -1, and for the full case, you have to check whether the value of top is greater than the value of the stack. Okay, length of the stack. Okay, or I can say value of the length of the stack -1, because the value of the length of the stack in this case is going to be equals to 5, but I have to check till 4 only. If the top is greater than 4, then I have to just say that your stack is full. Okay, so for the value of the top greater than 4, I will say that yes, your stack is full. So can I say that length of the stack -1 is going to be my last value, or I can say my top last value, the top last value for the top. Okay, so the greater value, the values greater than this is not acceptable. Okay, so top is going to be equals to, the last value of the top is going to be equals to length of stack -1 only. Okay, that is going to be my last element inside this stack. I can't add more elements over here. Okay, so I guess this was done. Okay, so we have to check for the whether the stack is full or not before we push something, and that's we can understand this thing. And if you want to delete something, we have to check whether the stack is already empty or not. So that's all about the algorithm part. And now let's have a look on the coding purpose. But guys, I am going to repeat this thing again, that if you guys understand the code, if you guys understand the algorithm, then try this by your own and then look at my code. It is going to be really fun then. Okay, so with this note, let's see how you are going to code this thing in Python. Before you conclude that I don't know how to code stack data structure, let me just tell you guys that I have only written this program, and I can write this program again in order to explain you guys. But the reason behind writing this code before explaining is that if I write the code and explain, then that is going to take a lot of time, and I have some time limits with this video. So I have already written this code, and now let's try to understand this code. But before understanding this code, let's first look on the structure of this program. Over here you can see lot of def. Basically it is a functions. There are a lot of functions with some parameters inside it. Okay, so why we are creating a lot of functions? Well, the reason behind it this is that you are going to deal with a lot of operations like push, pop. You are going to check whether your stack is empty or not. You are going to check whether your stack is full or not. After every push and pop operation, you are going to do this all things. And is it possible to do these things again and again? Well, no. So we are going to create function for these things, and whenever we need such things, we are going to call this function. So this is how we are going to save our time and our lines in code, and that's how we are going to get efficiency in a program. Okay, so over here I have created a lot of functions. Now let's talk about each and every function one by one. So over here the first function is def create stack. This is the basic function which is going to create a list for me and then return that list to me. Okay, so over here if I call this function, let me just show you guys that over here. So as you can see, I have called this function stack equals to create stack. So this function is called, and you guys can clearly see that this function is called, and the value of this function is passed to stack variable. Okay, so stack is basically a list, and this list is basically equals to this stack1. Okay, so I got a list, stack equals to list, stack1 equals to list, and stack equals to stack1. So I'm getting an empty list like this. Okay, so this is how you are going to create an empty list. You can also create like this if you want to. If you don't want to write that function, it's all okay. You can create a list like this as well. But for now, let's focus on the next part, and I'm going to create a list like this only because I want to create a function for each and every operation. Okay, so I've created a function for creating a list, or I can say creating a stack. Well, over here I'm creating a list, not a stack, because there is no data type like stack. but there is a data type like list, or I can say there is a data structure like list, because list is a built-in data structure. And I hope you guys know about this thing. And if you don't know about this thing, then I'm gonna put a PDF where you can study about the types of data structure. It's very simple. You can easily go through that PDF. Okay, so you have to just for now listen me that list is a built-in data structure, and our stack is going to be our user-defined data structures. So user-defined data structures are going to be created with the help of the built-in data structures. So in my case, it is going to be a stack, or I can say a list. So list is used to create a stack to get the extra features. Okay, so here I'm going to create a list first that is named as stack, and the next function is, so let's have a look on the next function. It is def and then empty. So what this def and empty is going to do? So def is empty is basically a function which is we are passing a parameter inside this function which is known as top. So the top is basically the pointer that is pointing to the topest value in a stack, and I hope you guys know about this. And over here we are checking about a condition, and then we are returning something. So basically this function is going to return either true or false. Below this function we have one more function as is full, and this function is also going to do the same thing, gonna return us true or false. Now let's see how it is going to return us true and how it is going to return us false, and then how we can conclude that it is empty or full. Okay, so when you look at the first def over here, you are saying that is empty top, and then you are saying that return top equals to -1. So over here we are saying that top is equals to -1. If this condition is going to be true, then this function is going to return us true, and if this condition is false, then I'm going to get false. Okay, so I'm going to return false value if this condition is false. If this top is not equals to 1, and if top is equals to 1, that means, of course guys, when top is 1, that means that we don't have any element, and if we don't have any element, we can say that our list is empty. Okay, or I can say our stack is empty. Okay, so for now let's talk about the next case, that is full. And in is full I'm passing two parameters, guys, because I have a length as well over here. For I don't know why I did this, but you can just pass length only, because I am assigning the value of length over here. So there is no issue when you pass length, but for now I don't know why, but I have put length equals to 5, so that I just want one argument, or I can say one parameter inside this is full function. Okay, so I'm passing top only, and then I'm checking whether top is greater than length -1, not equals to, but greater than length -1. And the reason behind this is that when you check the length, so length will be equals to 5 in my case. So the value of top, that is going to be index value, of course, that is going to go from 0 to 4. So the last value of top can be 4. If the value of top is greater than 4, that means 5. So over here my condition is getting false, because length -1 is going to be 4, and if the value is greater than that, of course condition is going to be true, and that means yes, our stack is full. Okay, our stack is full. Okay, so now let's have a look on the next function, and this function is really important because this function is the push function. So guys, I hope you know about the push function, because we have already talked about everything that you need to know in data structure, basically stack data structure. So push is the main operation in that. So what push function is going to do? Push function is going to take three arguments, or I can say three parameters. There are num. Num is basically the number that I want to add, or I can say the element that I want to push. Over here the top is the topest value, recent topest value, and we have stack, that is going to be the stack what I have. Okay, so now what I'm going to do is I'm going to first increment the value of top, and when you increment the value of top, you will be having a chance that your value can be 3, your value can be 4. So if the top value is 4, then the new value of top will become 5. And guys, when the value of top becomes 5, we know that we can't add new elements. So what we are going to do is we are going to check that if is false, if full. Okay, so is full is my function, and I'm going to go to this function, and top is passed to this function. The value of top is equals to 5 if the initial value of top over here is equals to 4. If I have 4, then now the updated value is going to be 5. So is full is going to check whether top is greater than length -1, and of course this condition is going to be true. Okay, so I'm going to be inside this if statement, because this condition is true. This is for loop, this is full is going to give me true as a return value. Okay, this is a function which is going to be a true value. Okay, so I'm going to be inside this if statement because I'm getting true value, and over here I am first going to decrement the value of top. And the reason behind this is very simple, guys. You are incrementing the value of top in the sense of getting a new element, but now you have no new element because your stack is full. So you have to first decrement the value of top in order to say that yes, my stack is full. If your value is incremented, then your top value will be 5, and we can't have the top value 5. Okay guys, so we have to first first decrement the value because we are not adding any element over here. And then we have to say that stack is full, and then we have to return the value of top because we have changed something inside this value. And over here, so we have to return the value of top. And then we have to, if this condition is not true, if my value is not greater than 4, I can say, then what I'm going to do is I'm going to just say stack.append num. Now what this stack.append num is going to do, this is going to append the number that you are passing, the element that you are passing at the end of the stack, or I can say this list. This is how the list is going to work. In C program, it is going to be slightly different, or I can say very different. We are going to talk about that in our next session or in a separate video. But for now, let's talk about Python. In Python, if you want to add something at the end, you are going to use append. And at the same time, guys, let me just tell you guys that if you want to remove something, you are going to use the pop operation. You are going to just say stack.pop, and in this way you are going to remove the last element. Okay, so over here we are then printing that we have added a new element because now our stack is not full, so we can add new element, and then we are going to return the value of top over here as well because top value is still changed by 1. Over here it is same, but still we are going to return. Okay, so we are going to return the value of stack, we are going to return the value of top over here. In the push and pop we are going to return only top. Okay, so over here let's have a look on this pop operation now. In the pop operation, you can see that we are passing 2 arguments only, that is top and stack, because we don't need to pass the number that we want to delete, because according to the stack data structure, if you want to delete a number, then that is only going to be the last number you added, or I can say the first number you added. Okay, so the last element of my list is going to delete it for the first. Okay, is going to delete for the first. So first I'm going to check that is my list empty or not, because if the list is empty, then how can I delete anything? Okay, so if the list is empty, then I'm going to just return top, and if the list is not empty, then I'm going to return then I'm going to just print that removed and what I have removed, and then I'm going to say that stack.pop, and this is how I'm going to just remove an element, and then I'm going to say that top equals to top minus 1, and this is the way you are going to remove element from the stack, or I can say a list, by using dot pop. Okay, and then I've just decremented the value of top because top is going to point the toppest value, and now one element is removed, so the value of top is going to decrement by 1. If you add one element, it is going to increment. If you remove one element, it is going to decrement. Okay, so at last I have just created a normal function which is going to show the entire stack to me. Okay, so now here let's come to the driver code, and driver code is the code that is going to be executed. Okay, so over here after line 32 at 33 we are having our driver code. Okay, so from 32 to 45 we have our driver code. So let's talk about this driver code over here. So let me just do it like this so that you can see this. Okay, so here you can see a lot of things. So let's first talk about this top equals to minus 1. We know that initially the value of top is going to be equals to minus 1 because we have to take our empty list. Then we have length equals to 5 because we know our last value, or I can say the maximum limit for the elements to be inserted inside this stack is going to be 5. You can change this thing, but you can't change this above value. Okay, so this is going to be fixed initially, not all time, but initially it is going to be equals to minus 1 only. And then you are going to say that create stack, and you are going to say stack equals to create stack. So you will be getting a return format of a list that is going to be named as a stack1, and stack equals to stack1. That means you have created a list. Okay, so I know this is a stupid function that is going to just create a list, but that depends on you. You can just write it list directly, or you can use that function. Okay, so then we are doing the important thing, that is top equals to push, and then we are passing 4, top, and stack. So let me just tell you that what is this 4? This 4, 5, 7, 9, 1, 10, all of these things are my numbers. Okay, so these numbers are going to be pushed to this stack, and then I have top to be passed inside this as a parameter and stack to be passed inside this as a parameter. So now all the operations that I have taught you above are going to perform, and according to these operations I'm going to get something. Okay, so let's visualize this thing over here. When I will pass 4, 4 will be added, value of top will be equals to 0. When I pass 5, 5 will be added, value of top will be equals to 2, or I guess 1. When I pass 7, value of top will be equals to 2. When I pass 9, value of top will be equals to 3. When I pass 1, value of top will be equals to 4. Now if I pass 10, then you guys know that it is going to go inside this function first, that is the is full, and it is going to check whether this is full or not. And you guys know that value of top is already 4, so if top plus 1, then I'm going to get 5. And you guys know that 5 is greater than length minus 1, that is 4. So if 5 is greater than 4, then this if statement is going to work, because the function is going to return true to us. This is full function is going to return true to us. So we are getting inside this if statement, and then we are going to first decrement the value of top, because see guys, we are not adding something, so why we are going to increment the value of top? So we are again going to decrement the value of top. We are going to say that stack is full, and then we are going to return the value of top over here. Okay, so at the last iteration, at the last point, when we are trying to add 10, we are not getting anything. Okay, so we are just getting this line over here, that is stack. What was the line? Okay, stack is full. Okay, so I hope you guys can see this line over here. Okay, so now let's see what happened after this. So I just printed top over here in order to explain the value of top at this position when you added this many elements. So of course it is going to be equals to 4 only, not 5. And now we are just popping two elements over here. You can easily understand this thing as well, pop and then stack. So in pop we have to just pass two parameters, that is the value of pop and then top and then stack. Okay, so everything is messed up, I guess. So pop, and then we have to pass two parameters that are top and stack. Okay, so inside pop we have to pass top. Okay, and then at last we are just printing the entire stack, show stack, and we are passing the stack inside this as a parameter. So I hope you guys can understand about this. If you guys still have any problem in this code, then don't worry about this. I'm going to provide you the source code link in the description where you can easily understand what is going inside this code. Okay, so here if I try to run this code, let me just run this code over here again, and you guys can see that new element inserted, new element inserted for the 5 times, but on the 6th time I'm getting that stack is full. And the reason behind is that I'm trying to add 10, which is going to add it at the index value 5, but the maximum index value that I can hold is going to be 4, so I'm going to get stack is full. And you guys can clearly see that the value of top I have already printed over here, print top. So this value will be equals to this 4 over here. And then I'm saying that removed 1, remove 9. Why remove 1 and remove 9, guys? Because see, I'm adding 1 and then I'm adding 9 and then I'm getting 1. Okay, so first I'm going to remove 1 and then after that I'm going to remove 9. If you guys still can't understand, then of course I'm going to provide you the source code over there. You can easily understand this thing. Okay, so after removing two elements, I'm printing this thing, I'm printing this stack. So you guys can clearly see I'm getting 4 7 5, and of course 7 was the last element, so it is coming at the last. Okay, so I guess that's all about this video. We talked about the stack data structure. We saw how the stack data structure is going to work, how you are going to code this thing. Importantly, we saw what is the algorithm for stack data structure. So I hope you guys enjoyed this video. With this note, I'm taking a leave now. Have a nice day. Take care. Bye.